Hey everybody. In class we talked about inequalities and the properties of inequality. Tonight we're going to work on using those properties to solve inequalities just like we would solve equations. And to see why this kind of stuff is important, let's take a look at this example problem here. Dylan's bank sends him an alert anytime his account balance drops below $150. He's planning a vacation for next week and you're helping him manage his budget. He currently has $600 in his account and is planning on spending $75 each day. On what day will he receive the alert from his bank? So in this case, we're not looking for when Dylan's account is going to be equal to $150, right? We want to know when his account is going to be less than $150 or below $150. So we can start this process off by using the star system, right? Let's use this to solve our problem. So we're going to study the problem. We're going to underline the question. On what day will he receive the alert from his bank? So let's use D to represent days. Okay, that's what we're looking for. Now, information that we need to know. We know that he gets an alert when his account drops below $150. We know that he has $600 in his account and is planning on spending $75 each day. Okay? So, he's planning a vacation. Yes, that's the situation, but that's not really going to help this problem. You're helping him manage his budget. We don't really need that information. But the rest of this is pretty important. So now we can write an inequality to represent this. We know that we want to know when his account is below 150 or less than 150. When is it going to be less than 150? Now we can represent the amount in his account by starting with $600, so that's where he starts at, and he's spending $75 each day. The amount is going to decrease by $75 each day, so we need to multiply 75 by the number of days. And here we have this inequality. Now, solving the inequalities is very similar to solving equations, but there's a couple differences. Really, there's one big difference. So we're going to put a pause on this problem. We're going to come back to it. We're going to check out a couple examples of what solving inequalities takes. Here we have two examples of inequalities, and we can solve these inequalities exactly the same way we would solve equations. Okay? Instead of having an equal sign, though, we have the inequality, but just like we do with equations, we'll draw a line between the two sides of the statement, separating the two expressions. We have the expression on the left, and we have the expression on the right. Now, to solve, we're going to do the same steps. I'm going to start with subtracting 2. That's going to give me 4x is greater than or equal to 6, right? The inequality sign stays the same. We bring that down. And then we divide by 4. And we get x is greater than or equal to 6 divided by 4. We could leave that as an improper fraction. We could simplify it. I'm going to write it as a decimal, 1.5, or you could write it as a mixed number, 1.5. And the reason it's nice to have it written as a decimal is because we can now graph it on a number line. We want to display the answers to our inequalities to show all of the possible values. So since I'm going to put my circle at 1.5, start at 0, we have 1, 2, 3. I'll label these like that, 1, 2, 3. I'm going to draw a little half mark in between each one, so now I can see exactly where my graph is going to go. So I'm going to put my circle on 1.5, and since x can be equal to 1.5, I want to make sure that's shaded in to show that that's a possible value, and x can also be greater than 1.5, so I'm going to shade in the numbers to the right. Okay, so here I have my solution, and here I have my graph showing the possible values that make the original inequality true. Now, let's try another one. We have similar problem here, right? Inequality. Now, this time it says 2/3 x minus 7 is less than 7. Same thing, we'll separate the two sides with a line. And we're going to start this problem by adding 7 to both sides. That's going to give us 2/3 x is less than 14. The inequality didn't change because we added to both sides. Now, problem here, I have 2/3 times x Now, I could do a couple different things. I could divide by 2/3, but remember, dividing by a fraction is really the same as multiplying by its reciprocal. So I think this will be an easier way to solve this problem. These will cancel. That'll give me 1. And I'm going to have x is less than, now I have to do 14 over 1 times 3 over 2. I'm going to use cross-canceling here to make this a little easier. I'm going to divide 14 by 2 to get 7. I'm going to divide 2 by 2 to get 1. 7 times 3 is 21. 1 times 1 is 1, so I get 21. X is less than 21. That's my answer. I have the variable by itself. It shows that x is less than 21. So we're going to graph that on our number line now. Draw our number line. Since we have a positive number, I'm going to put 0 over here, and I'm going to count by 7s. To make this nice and easy, we got 7, 14, 21, 28, and we'll put our circle now. X can't be equal to 21 here. X is only less than 21. So we're not going to shade it in because 21 is not part of the solution. Only these numbers that are less than 21 get shaded in. And there's our graph. There's our solution. We're going to take a look at a couple more examples here because there are some instances in which solving inequality is a little different than solving an equation. I'm still going to start by drawing my line, separating my two sides, my two expressions. And now I will do my normal first step. I'm going to subtract 15 from both sides. Okay? That gives me 0. I'm left with negative 2x. Don't forget that negative sign is less than or equal to 30. Now, I'm still going to do my next step that I would normally do if this were an equation. Divide by negative 2. But remember in class, we saw that if we divide or multiply both sides of an inequality by a negative number, we have to switch the inequality sign so that it points in the other direction. So now instead of less than or equal to, this is now a greater than or equal to problem. We have to make sure we switch that inequality when we divide by a negative number. Okay, we divided by negative 2 on both sides, so we have to switch that inequality. We saw that in class. So now we have our answer. X is greater than or equal to negative 15. Draw the number line. Put 0 over here. I'll go by 5s. 5, 10, 15, 20. We'll label those. And we will plot a circle at negative 15. Could be equal to, so we'll fill it in. X is greater than or equal to negative 15, and we'll shade in to the right because x could be greater than negative 15. Same situation over here on the right. Let me circle my answer here. Now on the right, same situation. We'll draw the line. Our first step, add 16, we know that. And that will leave us with negative x over 5 is greater than positive 6. Now I have negative x over 5. I need to multiply both sides by 5 to get rid of that 5 in the denominator. But I also want to make sure I end up with a positive x. If I multiply by a positive 5, I'm still going to have a negative over here. So I'm actually going to multiply by negative 5 on both sides. Right? My 5s will cancel out, and a negative times a negative will give me a positive. So I'll be left with x over here, and I'll have negative 30 over on the right. Now, because I multiplied by a negative number, just like when we divide by a negative number, we have to switch that inequality. So that's my answer. X is less than negative 30. We draw our number line. Let's count by tens here. We'll go 0, 10, 20, 30, 40. I'm just going to mark negative 20 and negative 40 here, and I can see the other marks still represent tens. And then we will draw our circle. It has to be an open circle because x can't be equal to negative 30, and x is just all of the numbers to the left of negative 30. All right, now we can go back to our original problem. We have this inequality that we wrote, 600 minus 75d is less than 150. We can do our steps to solve it, subtract 600 from both sides. That's going to give us negative 75d is less than negative 450. We divide by negative 75, and we're left with d on the left side. On the right side, we have positive 6, but because we divided by a negative, we must switch the inequality. D is greater than 6. So to answer the question, on what day will he receive the alert from the bank, he will receive it after the 6th day, not before. After the 6th day. Another way we could say that is on the 7th day, right? He's not getting it on the 6th day because D isn't equal to 6. D is greater than 6. So he will receive it on the 7th day.